Now, myself Jawaharlal, today I am going to discuss about the transformer, what is transformer and the working principle of transformer. Basically, a transformer is a static device which consists of two or more windings coupled by a common magnetic circuit. It transfers electrical energy from one electrical circuit to another electrical circuit through the medium of magnetic field and without a change in the frequency. The electrical circuit which receives electrical energy from the supply main is called primary winding, and the other circuit which delivers electrical energy to the load is called secondary winding. Each winding has a fixed number of turns. So actually, transformer is an electromagnetic energy conversion device. The primary and secondary windings of a transformer are not connected electrically but are coupled magnetically. Here you see there is a primary winding which is connected to the main supply, and this is the secondary winding. There is a laminated core. The core is laminated to reduce the AD current losses. And when this is the flux, when we put the primary on a main supply, then there is there will be a mutual flux which links to the secondary. So in next slide I discuss about how the transformer works. Here is the working principle of a transformer. You see, the transformer works on the principle of Faraday's law of electromagnetic induction between the two or more coupled circuits or coils. What is? According to this principle, an EMF is induced in a coil if there is a changing of flux. When an alternating voltage V1 is applied, here we apply the alternating voltage V1 is applied to the primary, and alternating flux phi is set up in the core whose amplitude will depend on the applied voltage and the frequency of the applied voltage. This alternating flux links both the winding and induces EMF E1 and E2 in them according to Faraday's law of electromagnetic induction. So the value of E1 and E2 depends upon the number of turns on the primary and secondary windings respectively, the magnitude of mutual flux also, and the frequency also. If the load is connected across the secondary, a load current starts flowing. Consequently, terminal voltage V2 will appear across the load. If V1 greater than V2, it is called a step-up transformer. On the other hand, if V2 is smaller than V1, it is called step-down transformer. So, you see here, first of all, it is an energy conversion device, and without the change in frequency, remember, without the change in frequency, it transfers the electrical energy from one circuit to another. Second thing, both the windings, here both the primary and secondary windings, these are not electrically coupled. These are coupled magnetically. So, this is transformer is also used for the isolation transformer. Safety purpose also is there. Now, the winding which is connected to the primary mains is called the primary winding. If any winding you can connect to the primary, that winding is called the primary winding. Now, when there is a step-up transformer, the number of turns of N1 is smaller than number of turns of N2, and for the step down transformer, N1 is greater than the N2. Now you see, this is the mutual flux. If you apply this voltage, then an EMF is induced in the primary also, and a mutual flux is set up. This mutual flux is changing So it is called the static device. The mutual flux is changing and it go to the primary winding. Due to the changing of mutual flux, the EMF is induced in the secondary also. And if you connect the secondary to the load, then an secondary current starts flowing. So this is the main principle of the working of transformer. Thank you. Please subscribe my channel for the next videos on the transformer and in the electrical engineering. Okay, thank you.